This unique combination measuring device from IoSys consisting of a mobile NIR-Infrared spectrometer, the so-called mIRo-part, and a patented spark spectrometer, the Spark-part, combines the advantages of both analysis methods in a portable unit the size of a pilot's suitcase. With this technology combination, almost all common types of plastic, regardless of color, size, structure such as solids, films, granules and regrinds, as well as carpets and textiles, can be identified, and additional elements in additives, especially in flame retardants and fillers, can be detected. The mIRoSpark comes with all necessary accessories and spare parts. There is an adjustable handlebar for safe transport, and for setting up the device. For setup, the 2-meter-long gray cable connected to the two measuring guns are released from their side retaining clips, unrolled, and then fixed directly into the measuring head holders, on the left and right, or hung on the side with the rubber tab. For transport, handling is carried out in the reverse order. Operation is possible via the integrated 10-inch touchscreen, and a PS2 keyboard. After switching on the device, the MS-DOS-based computer system boots directly into the mIRo program. The NIR spectrometer system should be recalibrated initially and from time to time. For this quick electronic and optical white balance, simply lock the mIRo measuring pistol in the left holder, or manually press the small white ceramic tile onto the measuring head, until the last message of the recalibration process has been displayed. To identify plastics using the NIR method, the sample is simply held in front of the mIRo pistol measuring head, and the measurement is started by pressing the pistol trigger. Individual or continuous measurements can be carried out in seconds. The easy-to-understand display of the transformed NIR spectra on the screen allows easy viewing and control of the results. The basic principle of NIR technology is diffuse reflection spectroscopy, in which the characteristic absorption behavior of various polymer types, in this spectral range is used. The plastic sample is irradiated with heat light and the reflected light from the measuring point is transported via a fiber optic cable to the self-developed spectrometer system, and analyzed with a special NIR sensor. The identification of different plastic types for both measurement methods is the result of trained pattern recognition, using specially developed neural network models within a database, with multiple cross-checks. The result of the calculation is a list of the most probable polymer types with a probability between 0 and 100%. For transparent, clear materials or foils, the small reflective ceramic, conveniently worn as a finger ring with a rubber band, must be placed behind the transparent parts, so that the scattered light reflects better into the measuring head back. When measuring films, a further fine differentiation can be made, in order to recognize also multi-layer films. Switching to other identification models is easy, using the corresponding symbols on the touchscreen. If the mIRo measuring gun is held upright, even small plastic parts, such as plastic flakes, pellets, granules or regrinds, from 1 mm in size, can be easily identified. To do this, the particles are just placed in the middle of the measuring head. The focus is approximately 4 mm. An integrated mini plotter prints out the result, including the NIR curve. An USB interface allows the data transfer. In the spectra mode of the mIRo program, up to 20 different spectra can be displayed, and viewed simultaneously in different colors. Operation, such as loading, saving, deleting and comparing spectra, is possible using the icons on the touchscreen, or using the external keyboard. In addition to the standard application, you can also develop your own measurement applications. By briefly pressing the respective pistol trigger, or via the respective icon, the mIRoSpark automatically switches back and forth between the two measuring programs. The basic principle of sliding spark technology is the thermal evaporation of a small part of the plastic surface, using a train of defined high-current sparks between the electrode gap, within approximately 1 second. The polymer and additive components are vaporized, fragmented, ionized and activated in the spark plasma to emit spectrally characteristic light radiation. The light of the spark discharge is transported via a fiber optic cable to the specially developed atom emission spectrometer, and analyzed with special CCD sensors. To identify plastics, the sample is simply pressed onto the spark gun measuring head, using the patented sliding spark process, so that the two movable tungsten electrodes have firm contact with the sample surface. The measurement is started by pressing the pistol trigger. After a second, the display shows the identified polymer type and possibly detected additives. When measuring gray-colored, clear, transparent, or dark, black, materials, you can also switch to other identification models for cross-checking, using the corresponding icons on the touchscreen. If significant elements, for example recycling relevant additives, are detected, such as flame retardants, containing chlorine, bromine and phosphorus, or lead and cadmium as additives containing heavy metals, the measurement result is displayed in red. Additive detection is generally based on the characteristic atomic emission for an additive element in the optical spectral range. The intensities of defined spectral lines are compared with preset threshold values. An element is detected when the preset threshold value is exceeded. These LOD values can be defined individually. With the existing calibration, with known samples from IoSys, the SPARC part of the mIRoSpark allows a semi-quantitative analysis of inorganic contents in the sub-percentage concentration range, down to 0.1%. When preparing the analysis sample with the SPARC part, which is a surface measurement method, and it represents the entire polymer material, it is recommended to remove dust and dirt or paint, thus it does not distort the measurement. The sample surface can be easily cleaned by scratching with a knife, so that the real plastic can be measured. From time to time, the sliding spark spectrometer system for polymer type identification should be recalibrated. For this electronic and optical white balance, the supplied reference plate is simply sparked off at 3 different places with the measuring pistol, and the recalibration process is started, using an icon until the last message has been displayed. In the spectrum mode of the SSS2 program, up to 9 spark spectra can be displayed, and viewed simultaneously in different colors. The operation, such as zooming and hiking in the spectra, in the wavelength range of approximately 220 to 600 nanometers, as well as detailed viewing and comparison of spectral intensities in tabular form, and other functions, such as loading, saving and deleting, can be done directly via the touchscreen icons or via the connected keyboard. In addition to plastic identification and element detection, this also makes it possible to develop your own analysis applications, using the sliding spark spectrometry. The measurement result with any detected additives can also be printed out using the integrated mini plotter. If empty, a new roll of thermal paper can be quickly inserted. The mIRoSpark, a unique, transportable desktop measuring device, for quick testing of all relevant thermoplastics, for laboratories and industry. mIRoSpark, the combined device for plastic identification, also for black parts, flame retardants and additives. IoSys, from Europe's leading plastic detection specialist.